Okay, 2.6, solving simple equations. So this is a brand new term we're going to talk about. You've seen it maybe in the past in elementary school, but we're talking about equations now. So an equation is a mathematical statement that says two expressions are equal. Okay, so here's an example of an equation where on the left side we have 2x minus 3. So in an equation we have a left side, and that's an expression 2x minus 3, and it's equal to another expression 5x plus 3 on the right side. Okay, and the idea behind equations is we're interested in solving equations. Okay, and to solve an equation is to find the value of the variable that makes this statement true, or this equation true. So what value of x can I put in here, and that same value of x that I put in here will make the left side equal the right side. Okay, so in this example, our final answer should look similar to something like x equals some number. Okay, some number could be a, could be some other number, could be a 4, could be a 10. So the goal is to find that x value. What x value will make that left side equal the right side? Okay. So in this case, well, we're going to get to that part. So we're going to get to solving equations soon. So therefore, our goal is to isolate the variable. So to solve for that, you do want to get x by itself. If you look at an equation like this, we do want to get x by itself and find out what that number would be. Okay. To check our solution, so after we find that x value, to check our solution, we can always substitute. Write that down here. Substitute that x value back into the equation to see if the left side equals the right side. Okay. So when solving equations, we always need to think what? Well, the way we solve equations is by using reverse operations. So think BEDMAS, but going in reverse. Okay, that means we look at any addition operations, we're going to be subtracting, and vice versa. Any multiplication operations, then we'll divide. So addition and subtraction come before multiplication and division, and same things for the squared exponents. Then we'll take the square root. Okay. So reverse operations, that's the key. Okay. So let's have a look at this balance scale. So when you look at an equation, think of it as a balance scale. It's only equal when the left side equals the right side, so that everything is in balance. Okay. Now algebra, at least little algebra tile thingies. I mean, this long strip represents an x, and these are individual numbers. So 1, 2, and 3. Here we have a whole bunch of them. So altogether we have 7 of them on the right side. Okay. So here's my example. I have x plus 3 equals 7. Excuse me. Oh. Okay, so I have an x here plus 3 more on the left side equals 7 on the right side. Okay, how can we isolate this x? We want to solve this equation. We need to find x. So think of it as, well, what happens if I remove these 3? Okay, we're going to remove these 3. If we do that, the whole balance scale is going to tilt to one side. Okay, we're going to remove this 3, then this becomes much lighter, and this thing tilts upward, and this thing tilts downward. So the only way to balance this out is if we remove 3 from the other side as well. Okay, so if I remove 3 from that other side, then I'll get just a single x on the left, and I have 1, 2, 3, 4 on the right. So x equals, x equals 4. So basically I subtract 3 from the left, and I subtract 3 from the right. Okay, and I'm left with x equals 4. Okay, so 3 plus 3 and take away 3 cancel each other out. 7 take away 3 gives me 4. Okay, so remember the idea is to balance the left side and the right side. Okay, if they can't balance, then you cannot solve your equation. So think about what could we do up here. How would we balance it? So we're going to come to multi-step equations later on, but we're going to go through a few simple examples. So solve each of the following. So remember, the goal is to isolate x, and to do so, we got to keep making sure we balance the equation. So to isolate x, we have this x plus 7, so reverse BEDMAS. We're going to reverse the order of operations. So we're going to reverse this to a minus, so we're going to minus 7 on this. But to balance it on both sides, you have to subtract 7 or take away 7 on the right side as well. Okay, so here I'm left with x equals 18 take away 7 is 11. Okay, let's look at b. X minus 6 is negative 9. So again, I'm going to reverse the order of operations. Instead of minus, I'm going to say plus 6. And to balance it on both sides, I also have to add 6 on the right side. So here I have x equals negative 9 plus 6 is negative 3. Okay, part C, negative 5 plus y equals 2. So x doesn't have to be the only variable. You could also have y. If I want to get rid of this negative 5 so I can isolate y, I should add 5 on this side. So if I add 5 on the left, I should also add 5 on the right. So these two cancel each other out, and I'm left with y equals 2 plus 5, which is 7. Okay, let's look at D. I have m as a variable here. If I want to isolate m on the left side, I should take away 4 from the left side. Whatever I do on the left, I should also do on the right, so I'm going to also take away 4 on the right. So these two cancel each other out, and I have m equals negative 6 take away 4, which is negative 10. And there's my answer. Okay, part E. Now, what if we're not being adding or subtracting? What if we're multiplying? So 4 times x. 4 times x equals 28. So what I want to do is isolate x, reverse order of operations. Instead of multiplying, I'm going to divide by 4. And to balance it on the right side too, you also have to divide by 4. Okay, so 4 over 4 cancel each other out. I'm left with x on the left side. 28 divided by 4 is 7. X equals 7. Okay, negative 2y equals 56. So negative 2 times y equals 56. If I want to isolate y, I need to divide by negative 2, both on the left and on the right. Negative 2 cancels with negative 2, and I'm left with y. 56 divided by negative 2. You might need your calculator for this one. You'll find that it is negative 28. Don't forget the negative sign. Okay. If you're not really sure about your answer, take your answer, put it back into the equation, check to see if the left side equals the right side. Negative 2 times negative 28 equals positive 56. Okay, and we just did our check. All right, so x over 6 equals 3. So if we're dividing on the left, I can isolate x by multiplying on the left. Whatever you do on the left, you do on the right, so I multiply on the right as well. So 6 over 6 gives me x by its left over, and 3 times 6 is 18. Here, same thing again. If I multiply the left side by 2 and I multiply the right side by 2 to balance it, I can get my answer. So 2 over 2 cancel each other out. And I'm left with h, which is what I want to isolate. And negative 7 times 2 is negative 14. Okay, and there you have it for the first part. Let's go to the second part. So, example. 2 times a number and 1 more is 5. What is the number? So this is kind of like a word problem you have to figure out. So we're going to have to define a number. So 2 times a number and 1 more is 5. What is the number? So the number is what we're looking for. So if we're looking for something, I'm going to claim that to be x. So let x be the number. Okay, so let's try to translate. You have to translate this statement into a mathematical expression. So 2 times a number. So 2 times a number. 2 times my number. My number is x. So 2 times x. And 1 more is 5. So I'm going to have 1 more. So 1 more plus 1 is like the word equal sign. So is equal to 5. Okay. There, what's the number? So now I have an equation. A little bit more complicated now this time. There's 2 steps to do this one. Okay. 2x plus 1 equals 5. Remember, the goal is to isolate x. Now, think about, well, do I divide by 2 or do I subtract 1? Remember, if it's 2 times x, you have to divide by 2. But if it's plus 1, I have to subtract by 1. Which one do you do? Think back to reverse operations or reverse BEDMAS. So this time, instead of going from left to right, you're going from right to left. So you're looking at all the addition and subtractions that are happening first. So here I have an addition of 1 happening. So first I have to deal with this. So to do that, I subtract 1 on the left and I subtract 1 on the right. These two go away and I'm left with 2x equals 5 take away 1 is 4. And then I can now divide both sides by 2. So then 2 times x, to get rid of that 2 and isolate x, I have to divide by 2 on the left and on the right. 2's cancel, x equals 4 over 2, which is 2. Okay, show your proper form as well. So x equal sign should line up with the fraction divisions signs. X equals 2 is my answer. So let's try solving these kinds of equations now. So 4x plus 3 equals negative 9. So first thing you're going to do is addition and subtraction first. So I'm going to deal with the plus 3. To deal with that, I have to subtract 3 on both sides. So these two cancel each other out. I'm left with 4x equals negative 9 take away 3 is negative 12. Then I have to deal with my multiplication and division. So I have a multiplication here. Divide by 4 to reverse the operation. Divide by 4 on both the left and then the right. So 4 over 4 is cancel each other out. X is what I have left on the left. Negative 12 over 4 is negative 3, which is what I have left over on the right. Part B, negative 2k minus 7 equals negative 11. Many more negatives, but the idea is the same. Deal with the subtraction first. So to reverse the negative 7, I should add 7. Right, whatever I add on the left, I need to add on the right. Okay, so negative 7 plus 7 becomes 0. I'm left with negative 2k on the left. Negative 11 plus 7 on the right side becomes negative 4. Now, if I want to isolate k, one more step I have to do is divide both the left side and the right side by negative 2. And so the negative 2's cancel each other on the left, leaving me with k. And negative 4 divided by negative 2 is positive 2 on the right side. Let's look at the next example. So part C, 5 minus w equals 18. Remember, I want to isolate the w. A couple of steps to do here first. So addition and subtraction. So a couple of ways you can do this. Okay, I could choose to add w on both sides, but it would give me an extra step. What might be simpler to do is get rid of the number. So subtract 5. Whatever I do on the left, I do on the right. So subtract 5 here on the right as well. 5 minus 5 cancel each other out, and I'm left with this negative w. So be careful with that negative sign. I have a negative w. And that equals 18 take away 5, which is 13. Okay, but I want a positive w. So if I want the positive w, I just have to either multiply or divide both sides by negative 1. Okay, because there's that invisible negative 1 in front. So negative w divided by negative 1 will give me a positive w. 13 divided by negative 1 is negative 13. And there's my answer. Okay, this is the same thing as saying, if I put this back up in here, it would be like negative of negative 13 equals positive 13. That's all it says. Okay, and my last one here, negative 4 minus 3a equals 8. So again, I have to deal with the addition and subtractions first. So let's try and reverse this negative 4 by adding 4 to it and adding 4 on the right side as well. So these two cancel each other out. I'm left with negative 3a equals 8 plus 4, which is 12. Then if I want to find a, I divide both sides by negative 3. So again, the next step in the reverse BEDMAS is to do the multiplication and divisions. So reverse those operations. So negative 3 times a, well, reverse it, I divide both sides by negative 3. So these two cancel each other out. I'm left with a. 12 divided by negative 3 is negative 4. And there you have it. Solving equations. It gets more complicated than this, but this is as far as we'll go for this lesson.